Hello everyone and welcome back to our channel Quaint. You have seen the title Orbital Angular Momentum of Photons, the Next Quantum Revolution. So a new term is there, Orbital Angular Momentum. You know angular momentum, but that is actually not orbital angular momentum. Means in most of the cases or most students know this term angular momentum, but that is actually spin angular momentum. That is not orbital angular momentum. If you study polarization of light, then in that case you can find that spin angular momentum, which has actually two values, either left or right, only two values for spin angular momentum, but we are talking about right now orbital angular momentum, and this is a special property. Actually, spin angular momentum of light, okay, this was discovered in the 1930s. But this OAM or orbital angular momentum of light was discovered in the year 1992. So this is comparatively a young field. Okay, anyway, so this can change or this can bring about a drastic change in quantum technologies. This special property. Normally, what do we know about light? That light reflects, it refracts, it makes colors, and the wavefront of light, that is like a flat surface, means like ripples in water. So simple, but actually light is not so simple. It's actually a quantum masterpiece. Light is actually a quantum masterpiece. Twisting of light is possible. Scientists twist light using different techniques or different devices, like spiral phase plates, like computer-generated holograms, then special mirrors, then Q-plates. They actually initially start with a laser beam, normal laser beam, and then using those devices, they imprint that special property, that is orbital angular momentum, on light. And that is what that comes from twisting. This orbital angular momentum, this special property, comes from twisting of light. So when light is actually twisted, when light is twisted by any means, suppose you have twisted light, in that case the wavefront does not remain flat. That in that case that looks like helical, like a corkscrew moving through space. Corkscrew moving through space, helical. Okay. In that case, that does not remain flat anymore. If you twist some way light, in that case, that thing happens. And this special property is being used, okay, to invent different technologies. Different technologies means, and we are talking about what? In the title you have seen, the next quantum revolution. That means we are talking about actually quantum communication, quantum computing, then high dimensional physics, then optical microscopy, astronomy. So many fields are there where the researchers are actually conducting their research work to use that special property of light, that is twisting of light, or better to say here in our discussion, OAM of photons. Okay. That special property is being used to develop all these things. High dimensional physics means I was talking about actually quantum sensing, quantum imaging, quantum algorithms, these things. So many things are actually there. Anyway, how you can observe that twisting of light. Say for example, you have a laser beam, twisted laser beam. Means using those devices, Q-plates or special mirrors, or computer-generated holograms, or spiral phase plates, you have twisted light. So if you shine a twisted light onto a screen, you can see a special pattern. Yes, something incredible actually appears here. A donor-shaped pattern. A donor-shaped pattern you can see on that screen. And at the center, you can see a hole, and which is dark. And this happens due to phase singularity of light. where actually light cancels itself out. Better to say this. Light cancels itself out, and that is known as phase singularity. Of course, this is happening due to that twisting of light. If you shine a normal light onto a screen, in that case, you cannot see that donut-shaped pattern. But if you shine a twisted light beam onto a screen, in that case, you can see that donut-shaped pattern. Okay. The center, you can see a hole, but that hole is dark. No light is there. But around that hole, there is a bright ring. Energy spiraling outwards. And this tells us the presence of that special property, that is orbital angular momentum. And this pattern is called actually vortex beam. This pattern, what you can see on the screen, this donut-shaped pattern, this is actually called vortex beam. So this special thing you can see just because of that twisting. Now, twisting, there are different amounts of twisting. Say for example, one twist per one wavelength, per wavelength. Better to say per wavelength. You can see one twist per wavelength. You can assign this as +1. +1. Why plus? I am saying plus because minus also can be there. If for one direction, say for clockwise direction, we are talking about twist. That means there is a rotation. So, for example, for clockwise, you are assigning plus values. So, for the opposite direction, anti-clockwise means counterclockwise, you need to assign negative values. So, +1, -1, +2, -2, that way. And if there is no twisting, in that case, it is 0. So, these numbers are denoted by a letter, that is L, actually fancy L, okay, fancy L is used, and this is called topological charge. Name is assigned, a special name is assigned, topological charge. So L is equal to +1, that means this is the topological charge of that light. Topological charge. Actually, better to say here photon or that light particle. Topological charge. So this can be +1, +2, +3, all the way to infinity. There is no upper limit. Okay, +1, +2, +3, that way +10, +100, +1000, no upper limit. That's why I have said all the way to infinity. Exactly in the negative direction also same thing, -1, -2, -3. Negative direction, negative values means just the opposite direction and nothing else. Okay, twisting in the opposite direction. So +1 means one twist per wavelength. That is the meaning. So all these twists are what? These are quantum states. So just for a photon, if you consider +10, L is equal to +10, means topological charge is equal to +10. So 10 twists per wavelength. So more twists, that means it can hold more information. A single particle can hold more information. Now if you compare this with a qubit, you know qubit, only two states are there, 0 and 1, means Ket 0 and Ket 1. Only two states are there. Qubit is limited by the number 2. But in case of this is a special thing and name is given Qudit. Qudit, this name is given. Okay, and you can see here there are more than 2 states and actually there is no upper limit. So more states means you can manipulate, scientists can manipulate these more states to hold more information. So a single particle can hold more information. So where, say for example, for a particular task, a quantum computer is required and millions of qubits are required. Okay, to accomplish that task, say for we are talking about computational chemistry. So in that field or in drug discovery, these are the requirements. Anyway, for those things I'll make a separate video. I'll make separate videos to discuss all those things in detail. So anyway, for example, you need a quantum computer where millions of qubits are required. So same thing can be done using qubits. If number of twists per wavelength is more, that means if topological charge of the photons is more. Say for example, a few thousand qubit or few thousand photon can do the same thing. Increasing the number, scaling the number of qubits is not a joke. It's not so simple. Anyway, that's why scientists are thinking about these qubits, and these are actually naturally available. So that's why these are called natural qubits. So now you know the meaning of this orbital angular momentum. So this orbital angular momentum is coming from where? It is coming from that twist, not spin angular momentum. This is orbital angular momentum. Okay, and since you can drastically reduce the number of particles used in your device, so scientists are expecting that this can bring about a drastic change in the world of technology, in the future technology. So many future technologies are there. One by one, I'll make videos on all the topics, if possible. Okay, if time allows. Anyway, so this was all about today's topic. This was all about today's topic. Okay, so here, what is the main thing? Number of quantum states available for a single particle is more. What is the upper limit? Limitless. There is no actually upper limit. So, in case of high dimensional physics, you can use this special property OAM, orbital angular momentum. Anyway, so this was all about today's topic, and this is the end of this video. If you found this video fascinating, so please like, share and subscribe to our channel. This is the end. Thanks for watching.